Every single second, our digital world is under attack. We've got these digital guardians called Security Operations Centers, or SOCs, standing watch. But here's the problem. What happens when they're all shouting warnings, but in totally different languages? Today, we're diving into the SAFE4SOC project, a really ambitious plan to get our isolated defenders to finally work together as one unified army. All right, let's make this super simple. Just imagine a massive fire tearing through a city. Now, what if every single fire department used a different radio? No coordination, no sharing info on where the fire's heading, can't call for backup? It'd be total chaos, right? Well, believe it or not, that's pretty much the exact problem we're facing in cybersecurity right now. So, here's our game plan for getting from that chaos to real collaboration. First, we're going to look at why our defenses are so broken up. Then, we'll see how we can build a common language and a totally secure way to share information. After that, we'll see it all in action. And finally, we'll unleash the massive power of collective intelligence. So let's start with this fragmented defense. I like to call it the Cyber Tower of Babel. It's the perfect analogy. You've got all these sentinels in their own isolated towers, and they see an enemy army approaching. They're all shouting warnings, sure, but nobody understands each other. That's pretty much the state of our cyber defense today. The heart of the problem is this. Every single security tool from every different company spits out alerts in its own unique private format. So when one team spots a major threat, they can't just instantly blast that warning out in a way that everyone else's systems can automatically understand. In the heat of the moment, when you need it most, real-time collaboration is basically impossible. So how in the world do you solve a Tower of Babel problem? Well, you create a universal translator, right? This next part is all about building that Rosetta Stone for cybersecurity, a common language that every single security system can speak and, more importantly, understand. And this universal language, it actually has a name, IDMEFv2. The easiest way to think about it is like a universal fill-in-the-blanks form for describing a security incident. It standardizes everything. So an alert about malware from System A means the exact same thing with the exact same data fields to System B, C, and D. This is the foundation for, well, everything else we're about to talk about. And just look at the difference here. I mean, it's night and day. On the left, you've got total chaos, 3 different alerts, all talking about the same event, but in ways that no automated system could possibly understand together. Then, on the right, you have the beautiful clarity of IDMEFv2. One clean, structured, predictable format. Everyone gets it. Okay, so we've got a common language. That's a huge step. But how do we actually share messages in this new language without, creating a bunch of new security risks? Let's move to the next piece of this puzzle. A kind of trusted digital messenger that's smart enough to control the flow of information. And this is it, the Information Sharing Gateway, or ISGW. Now, think of this thing as a super intelligent filter, not just some dumb mailbox. First, it grabs that standard alert. Then, it applies a bunch of pre-agreed rules, like stripping out private info. After that, it actually enriches the data, maybe adding new context. And only then does it send the polished, secure alerts on its way. But who makes up these rules? Well, that's where something called Information Sharing Agreements, or ISAs, come in. An ISA is basically a digital contract. So for instance, 2 banks might agree to share threat data with each other, but the ISA would make absolutely sure that no private customer info ever gets exchanged. It's all about sharing what you need to, but in a way that's controlled, compliant, and totally secure. All right, so we have the language and we have the secure messenger. Now for the fun part. Let's see how this all comes together in the real world. This is where we stop talking theory and start putting the system to work to create a truly united front against cyber attacks. The first and maybe most critical use case is defending our national infrastructure. We're talking about the power grid, our transportation systems, healthcare. I mean, a successful attack on any of these could be absolutely catastrophic. SAFE4SOC allows all of these different operators to report threats to one central authority in real time, essentially creating a national shield. And here's the thing. This isn't just some nice-to-have idea. It's often a legal requirement. New regulations are mandating this exact kind of rapid reporting. So the key takeaway here is that a system like this not only dramatically improves national security, it also helps these organizations tick a really important legal box. Another really powerful application is in defense. Think about it.
An army's forces, land, air, and sea, are all operating with wildly different systems and technologies. SAFE4SOC creates a clear hierarchy where alerts can flow from individual bases up to their commands and then all the way up to a central headquarters.
Because at the end of the day, a military commander needs one thing above all else: total situational awareness. This system provides that single, unified view of the entire battle space, both cyber and physical. It allows for truly coordinated command and control. And this is what's so cool. You can really see the flexibility of the framework here. Whether you're a big corporation, a critical infrastructure operator, or the military, the model is exactly the same. You have a sender and a receiver sharing information securely according to the rules. It's a solution that can work for just about anyone. So let's bring all this home. What is the ultimate payoff for connecting all of these different systems? It's about creating something that's way, way bigger than the sum of its parts. It's about creating true collective intelligence. Because, we really are stronger together. This diagram just nails the end goal perfectly. We're moving away from all these isolated security centers, each with their own tiny peephole view of the world. Instead, their individual alerts all feed into one central hub. And this hub doesn't just collect the data, it analyzes it to create one single, unified, big picture of the entire threat landscape. And the benefits here are just huge. First, you get central monitoring, one screen to see everything. Second, you get a much smarter defense. With this massive pool of data, AI can spot large-scale coordinated attacks that would be completely invisible to any single organization on its own. And finally, this process creates brand new intelligence that then gets shared back out to everyone, making the entire network stronger. It's a virtuous cycle of security. And that really leaves us with one last thought. We have gone to these incredible lengths to build a common language, a system of trust, all so our machines can finally work together to defend us. It kind of makes you wonder, what's stopping us humans from doing the same thing?